So, last class we have discussed that when the light is entering from rarer to denser medium, how it will deviates or it will bends, as well as when it is entering from denser medium to rarer medium, how it will deviates. That is all we have all studied. Is it yes or no? Yes? Tell me.
Yes, sir.
Yeah. So, as well as when we finally we have concluded that when the light is entering from rarer medium to denser medium, it will bend towards to the normal, as well as when the light is entering from denser medium to rarer medium, it will bend away from the normal. Is it yes or no? And the main point which you have to remember is when the light is entering from rarer medium to denser medium, the speed of light will decreases, as well as when the light is entering from denser medium to rarer medium, the speed of light will increases. That is what we have studied in the last class. Is it yes or no? So now, same way, we have drawn the ray diagrams when the light is entering from rarer medium to denser medium, in the same way from denser medium to rarer medium. And after that, we have taken a case that when the light is going from air into glass and again from understanding again into air, means from the glass into air. That is what we have drawn. Refraction of light through glass slab. So 2 times refraction will take place. 1 time from air into glass it will enter, and again from glass into air. So that ray is only ways to go, the light ray which is emerging out from the glass slab, which we used to call as emergent ray. Is it yes or no? Which we used to call emergent ray.
Emergent ray.
Yeah. So and always, as we know that incident angle, understand, incident angle and emergent angle are always equal. Is it yes or no? Incident angle
Yes.
and emergent angle is always equal, and angle of refraction is always less than angle of incident. That is what we have concluded in last class. So I hope till here we have written all the things. Is it true? Is it true? So now you may notice it. Now you may ask me, finally we have concluded that actually it needs to travel. If you take a glass slab, observe very carefully all of you. If you take a glass slab, you have inserted light like this and it is deviated like this, and again it is going into the same path, which is like original path. Is it yes or no? And the new path, the distance between the original path of the light and the new path of the light, the distance between that is only ways to call as what? One name I have told you. What is that? What is that? Lateral displacement.
Lateral displacement.
So lateral displacement, which we used to call as. Understand? So actual path is this one, but due to refraction, it is traveling and it is taking new path and it is traveling. So that the distance between that actual path of light and the new path of light is only called as lateral displacement. Understand? So here you remember why they become parallel here means finally. Understand, the imaginary original path of light and the new path of light, why they are parallel means, what is the sides of rectangular glass slab? Is it they are parallel or not? Is it they are parallel or not? All of you?
Yes, sir.
Yes? So that is the reason why these will become parallel, because the light is entering through a parallel glass slab. Suppose if we take prism, which we will study in the chapter 2. So there they are not parallel. They are having some inclination so that the refraction of light will not become parallel. It will go some other direction. So that is we will study in the chapter 2. So here you should remember the important question is why here the parallel, these are parallel, because the rectangular glass slab, they are having a parallel side so that the light is also the original path ray and the new path both will become parallel. Do you understand? All of you?
Yes, sir.
Yes. So now Also, you remember, and also I have told you that. Suppose I want to increase this lateral displacement. Understand? Some person, suppose I have, as we have discussed, Pranav will take this much a glass slab, and another one will take. Suppose Dileepan will take. Sir, I will take the very big glass slab like this, and some other will take. Arya will take very small glass slab, which is having a very less thickness. Then everywhere the light will become, you can see the same way the refraction will take place when it is entering from air to glass, again from glass to air. But here the thickness is matter. That is what you should remember. Understand, everywhere it is glass only, but few parameters which will, understand, change the this refraction, the bending of light, as well as understand the lateral displacement and all. So what is that means? You remember, always you remember the refractive index of this glass slab or else this lateral displacement, both they are directly proportional to angle of incident. That is what you should remember. So the first parameter which will understand change this lateral displacement as well as the refractive index of glass slab. So the angle of incident, the thickness of the glass slab, and the refractive index of glass slab. So these are the main three factors which will depends, understand, which will varies the lateral displacement of the glass slab. That is what you should remember. So this lateral displacement, either it is smaller or bigger, understand, it is very, very smaller. It is always depends on three factors. The three factors only: refractive index of glass slab, and as well as the thickness of glass slab, and as well as the angle of incidence. What is the angle of incidence? Understand, you are inserting. Some person will insert with less angle of incidence. Understand? And another person will insert with a more angle of incidence. Like that, depend upon the angle of incidence, the lateral displacement will varies. But how it is, either it is increases or decreases, now we should know. So as we know that the perpendicular distance, you may observe this perpendicular distance between the original path of incident ray and the emergent ray which is coming out of the glass slab is only called as lateral displacement of the, understand, emergence ray of light. Now here you see these lateral displacement depends on three factors. Everybody must know that. One is angle of incidence, and the next one is thickness of the glass slab, thickness, and as well as refractive index. Now, how it will vary, we'll see. Refractive index. Understand, if it is increases, if it is decreases, what will happen? You can observe here very carefully, all of you. Actually, lateral displacement is, understand, directly proportional to angle of incidence, thickness of the glass slab, and refractive index of glass slab. So means in the sense of what? If you increase these values, then lateral displacement will increases or decreases? Nobody is answering. These all angle of incident, thickness of the glass slab, as well as refractive index. If these things are increases, then lateral displacement also increases. Means in the sense of they all are directly proportional to each other or inversely proportional to each other. It is increasing, it is also increasing. Yeah. If this is decreasing, this is also decreases. What will happen? If refractive index increases, lateral displacement increases. Understand? If angle of incident is increasing, lateral displacement is increasing. If thickness of the glass slab is increasing, you can compare here. Arya is taking small. Understanding? Pranav is taking a little bit bigger, and Dileepan is taking a little bit smaller. Then this person is having more thickness, big thickness, so that here the lateral displacement is more. Because thickness is more, then the lateral displacement is also more. Do you understand? So these are the three factors which will always, understand, increase the lateral displacement. Do you understand?
Yes, sir.
Yes, sir.
Yes, sir.
So this is an important question. That is what you should remember. Understand why it is parallel and what is the factors which will increase the lateral, understanding, displacement. This is a very important question from this paragraph. And as we know that the angle between the emergent ray and the normal is called as angle of emergence. Is it true or not? Is it true or not?
Yes, sir.
Yes or no? So the angle between the
Yes,
emergent
sir.
ray and the normal, which we used to call it as angle of emergence. So now if we'll take here, always this angle of emergence, understand this emergent ray is parallel to the original light ray. So that is why we can say the angle of emergence is equals to the angle of incident. Do you understand? Angle of incident.
Yes, sir.
Okay. So now
Yes, sir.
the same kind when the light is entering from, understanding the light is entering from air to glass slab and again glass slab to air. If we'll take the same instead of glass slab, if we'll take water also, the same thing. If we'll get a same understanding that if you pass the light through the water, then there also the same thing. If the if the air light is traveling from air into water and again from water into air, we used to get the similar ray diagram, understanding, which has been related to the like air to glass and again glass to air. But there water refractive index is constant, understanding, so that the deviation of light is same. But if you take the glass, understand, different glass, all are transparent, everything is glass slab only, but different glass slabs is having different refractive index. So every glass slab is having different kind of refractive index because we have a types of glasses. You may see that cone glass, normal glass, like that. So the refractive index is varies. So that is why the lateral displacement also varies. Do you understand, Ra?
Yes, sir.
So that is what is to called as refraction of light through glass slab and again from glass slab to slab. So now let us show me one picture. You may understand very well. Through the glass slab, if you'll observe, what will happen? Understanding how we can find the refractive index, refraction is taking place. So that is what you should see. Suppose if I see your fingers through the glass slab, then how you can able to see what is the refraction will takes place. That is all you can observe. So now all of you observe in this picture. All of you observe in this picture. Can you able to see here? So here refraction is taking place. Have you noticed it? Have you noticed?
Yes, sir.
This is
Yes,
what
sir.
the figure which I am observing here. So here what is happening? Can you able to say? If you'll observe here in this picture, understand? So the lateral displacement of finger caused by the refraction of light through the glass slab. Is it yes or no? Have you noticed it? Lateral displacement. This is the new path. This is the image of the finger which we are seeing, but the original path is like this. Have you noticed it? Original path is this
Yes, sir.
way. But here the new path is happening. So both are, if you'll see, both are parallel to each other. Is it yes or no? Because this rectangular glass slab is having what? A parallel sides.
Parallel.
Why the original light ray and the original path of the light and as well as the emergent light ray which is coming from the glass slab, both are parallel always because they have a parallel sides. That is the reason you should remember. Understand? So now, is there any doubt how we can increase the lateral displacement? 3 ways. What is that? How we can increase the lateral displacement?
Angle of incidence,
Angle of
Angle of
thickness,
thickness,
refractive index
refractive
of the glass slab
refractive index,
thickness,
and angle of incidence, refractive index, and as well as
thickness.
thickness.
of the glass slab. That is what you should remember. That is very, very important question. So many years they used to ask. But how? If I will increase the angle of incident, then what will happen? Understand? Angle of incident. Then the lateral displacement will increases. But what is lateral displacement? That perpendicular distance between the original ray of light and the emergent ray, which is coming from the glass slab, is only called as lateral displacement. So that is what it is. So for this question, understand. So we have drawn the ray diagram. Is it yes or no? In last class we have drawn the ray diagram. Is it correct?
Yes, sir.
Yes.
Yes, sir.
So the explanation and that
Yes.
answer, everything I will give you as a classwork because it is like writing. It will take more than one period. So I will give you that answer directly. So that explanation you should learn. But the 3 points you should remember here. Understanding. One is always angle of emergence which is equals to angle of incident and the angle of refraction is less than that angle of incident. Do you understand? That is the first point you should remember. Next, second point, what is lateral displacement? And the third point, what are the factors which will influence the lateral displacement? These 3 points should be included whenever this question is usually asking in exam for 2 mark or 3 mark, it doesn't matter. Whenever they will ask this question, this 3 point you have to include, as well as you have to name the glass slab properly, like PQRS or ABCD, whatever it is you have to take. And the explanation means what? Means nothing. Let us take the incident tray AB. Then after striking the point at O, it will be refracted towards to the normal because it is entering from rarer medium to denser medium. So that the refracted ray is called as OB. Like that we have to explain. That's all. So like it will bend towards the normal or away from the normal and all. So that is all. Generally, I will give you the one direct what is the explanation you should do, because textbook and all it will be very big paragraph, so that we cannot write that all. I will give you that so we can easily learn it. Now you should write under that diagram, you should write the 3 things. Write it. All of you should write. Already first point you have written it. Angle of incident which is equals to angle of emergence, and it is angle of refraction is less than the angle of incident. That is second point. Lateral displacement. All of you should write. Lateral displacement. Lateral displacement. Lateral displacement. Right. The perpendicular distance. The perpendicular distance. All of you should write. The perpendicular distance. The perpendicular distance. Is there anybody having any doubt? You can ask me. The perpendicular distance between the original path of incident ray, between the original path of incident ray, between the original path of incident ray and the emergent ray, and the emergent ray. So many yet to join. Please make a call for them. Karthikeyan, are you understanding?
Yes, sir.
Right. The perpendicular distance between the original path of incident ray and the emergent ray, and the emergent ray, and the emergent ray coming out of the glass slab, coming out of the glass slab, coming out of the glass slab, coming out of the glass slab. Pranita, Jesse is not yet joined. We can make a call for them. Somebody. Coming out of the glass slab is called.
Sir, I'm there, sir.
Oh, okay. Coming out of the glass slab is called lateral displacement. Is called lateral displacement. Is called lateral displacement. Is called lateral displacement of the emergent ray of light, of the emergent ray of light, of the emergent ray of light. That is the second point. Is there any doubt, anybody? Tell me. Next point, third point. Third point you should write. Lateral displacement depends. Lateral displacement depends mainly on 3 factors. Lateral displacement depends mainly on 3 factors. Lateral displacement depends mainly on 3 factors. Mainly on 3 factors. Mainly on 3 factors. First one, angle of incidence. Angle of incidence. Second one, thickness of the glass slab. Thickness of the glass slab. Thickness of the glass slab and refractive index of glass slab. And the refractive index of glass slab. Refractive index of glass slab. Next point. Higher the values of these factors, 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 greater will be the lateral displacement. Greater will be the lateral displacement. Higher the values of these factors, greater will be the lateral displacement. Greater will be the lateral displacement. Do you understand, all of you? Yes or no?
Yes, sir.
Yes, sir.
Yeah. So that is. So all are directly proportional or inversely proportional to each other? All are
Directly.
directly proportional. That is what
Directly.
you should remember. Understanding. Note you can keep and you write. Lateral displacement is directly proportional to all these factors. Lateral displacement is directly proportional to all these factors. All these factors. Lateral displacement is directly proportional to all these factors. So if you understand that, then you can keep heading. Now, this next thing, which is most important thing. So till now we have studied that angle of incidence, understanding, which is little bit understanding less than perpendicular normal. Is it in the sense of we are always inserting the incident ray with some incident angle, means some obliquely we are inserting. Now suppose the next concept is, if in the case of light falling normally or perpendicularly on the glass slab, then how the refraction will take place or not, that is what we all need to study. So the next concept which we are going to study is, all of you keep heading, the case of light falling normally, the case of light falling normally. Normally also we can call it as what, Amma? Normally also we can call it as perpendicularly. All of you should remember. Normally on a glass slab. On a glass slab. Perpendicularly. Normally also we can call it as what? Normally also we can call it as what?
Perpendicularly.
Nobody should forget that, because if you exam most of the cases they will give normally. If it is missing, then they will give you understanding. Now perpendicularly. Let us observe now. Understand. All of you first listen. This is the most important concept. So all our discussions is for, we have assumed that the incident ray falls obliquely, means which is making with some angle with understanding normal. So that is what we have studied, how the refraction will take place, how the bending will take place. And now itself I am saying that if you want to show the refraction, the light ray must be false, understand, with some obliquely. Is it yes or no? Yes or no? Yes or no? Yes. So then only the bending of light rays will take place in the glass slab and whatever it is we have studied till now. Now if you take, if the incident ray falls normally, observe all of you, I am taking, this is the glass slab now. Let me take the single ray of light now, not understanding normal beam of light. If I will take a single understanding ray of light, let us observe very carefully, all of you. If the incident ray falls normally or perpendicularly to the surface of glass slab, then no bending of ray of light and it goes straight. How it will go? How it will go, sir? It will go
Straight.
So if you insert the incident ray, understand? If you insert the incident ray perpendicularly to the surface, then the light ray will go straight without any deviation. Without any deviation. That is what will happen. But you observe, what is the angle of incident here? What is the angle of incident here? So this is what? Incident ray. AO is the incident ray, and as well as, understand, which is coming outside at the point B. Again it is leaving out. So let us take that ray is called as BC. So now you tell me, what is the angle of incident here? This is air and this is the glass and this is the air here. So now, what is the angle of incident and what is the angle of refraction here? No refraction. I am saying that no refraction. So means in the sense of, what is the angle of refraction? No refraction. What is the angle of refraction? Angle of refraction, tell me.
Zero.
refraction is equals to
Zero.
0 degrees. Understand?
Zero.
Now, same way, you observe very carefully. This is the normal, and the light ray is passing on this. Then, as we know that, if this is the normal, if the light ray is inserted like this, then the angle between this is the angle is present between the normal and the incident ray is called as incident angle. Now, both become equal, same. Both are coincident.
Zero.
Then, what is the angle between them? What is the incident angle between
Zero.
them? 0 degrees. Sorry.
Zero degrees.
That is what you should remember. So the incident angle is 0 degrees, and as well as angle of refraction is also 0. So angle of incident and angle of refraction both will become 0 in the case of when the light ray falls perpendicularly to the surface. But what is the angle between the surface and the incident ray? What is the angle between the surface and the incident ray? What is the angle between surface and incident ray? Suppose in the case of here you may see normal, incident ray, and this is the refracted ray. This is called as angle of incident and this is called as angle of reflection, or you can take in the form of refraction. Now this is, what is this angle? Suppose this angle is 30 degrees. This is also will become 30, and this is how much amount? 90 minus 30. How much it is? We have studied at the beginning. How much it is?
60 degrees.
Sorry, 60 degrees. Now same way you tell me here, what is the angle between the incident ray and the surface? What is the angle between the incident ray and the surface?
90.
This angle is how much?
90.
90 degree.
That is what? The angle is 90 degree because incident ray and the normal both are coinciding each other. So that angle of incident is 0 and the angle between the surface and the incident ray is 90 degree. The same way, here also the angle between the light ray and the surface is also how much it is? This is also
90 degree.
90 degree.
That is what.
90 degree.
But light ray is entering from rarer to denser and the denser to rarer again. So that what will happen? Here and here, the light ray will travel with the same speed, but in middle, speed will decreases or speed will increases. Anybody? Speed will decreases or speed will increases?
Decreases.
Speed will
Decreases.
speed will
Decreases.
decreases. That is what you should remember.
Decrease.
Decreases here. Understanding? But no refraction. Understanding? No refraction will take place because it is going, it is falling perpendicularly, understanding, or normally to the surface. That is what the thing you should remember. Now, same way, you take the beam of light. A beam of light will fall on a glass slab. Then how it will be happens? All of you can able to say how it will happen? Now let us take now a glass slab. Again the glass slab. Let me take the glass slab. This is what my glass slab. Now I have taken a beam of light. Beam of light in the sense of what? We can take different colors. Is it yes or no? So now different
Yes,
backlit colors I will take.
Yes.
So that what will happen? So this is what the beam of light which I have taken. Now you tell me. So where it is having, what is the angle of incident here? Here also it is falling normally to the surface. Now, if we take here, this is the beam of light. Beam of light rays. So as we know, here and here, it is having a, understanding, same speed. Is it yes or no? So that light ray can travel, understand, with the same speed and the air and again here also air and air. But in middle, what will happen? Middle, what will happen? The speed
Speed reduces.
will reduce.
Decreases.
So that means
Decreasing of speed.
how we can represent the particles will become closer. Do you understand, Igra?
Close.
Speed will decrease. So how we can show variation means the lines will become very closer. So that is indicating the speed of the light is decreasing inside the, but still it will travel how? It will travel, understand? Same straight line perpendicularly to the surface because it is falling normally or perpendicularly to the surface so that no refraction will take place. No refraction will take place. That is what you should remember. Always, all of you write. So, wherever it is point is inserting A, B, and again C and D. So, no refraction, they will go straight line. But here and here, you can observe the Understand, speed of light is same because both the mediums are same. Same way like here. That is what you should remember. So here also no refraction of light when the beam of light also, or else when it is a single ray of light also, no refraction of light will take place. Do you understand, all of you?
Yes, sir.
Yes.
Sir.
That is what you should draw. So you have kept the heading, the case of light falling normally on a glass slab, then you write the first statement and you draw these two diagrams. All of you write. But naming is important. I forgot. Here you have to name it. What is the glass slab naming? PQ
PQ.
RS. Without naming it is invalid. Understand? PQ. All must be having proper name. Everybody must remember that. That is what you can see here. AOBC. The same way here. ABCD and PQRS. Everything should be right. Right. Do you understand, Ra? When the light ray falls perpendicularly, what will happen? No bending of light. Means no refraction of light. So that angle of incident is 0. Angle of refraction is also
Zero.
is also 0. That is what
Zero.
you remember. Right. If the incident ray falls normally, if the incident ray falls normally, with the scale you draw, equal distance. This is equal distance and this is some other equal distance. Little bit increases and you write it because it shows that speed is more compared to here. That is what it represents. That's all. Understand, Pranita? Right. The incident ray, call to Jesse and tell her to join. If the incident ray falls normally, or perpendicularly to the surface of a glass slab, if the incident ray falls normally or perpendicularly to the surface of a glass slab, then there is no bending of bracket. You can write no refraction. There is no bending of the light. Bracket you can write no refraction. Bending of light, comma, and it goes straight. Do you understand, all of you? And it goes straight. That's all.
Yes.
So you can draw these two diagrams, all of you. No refraction. And refraction is also angle of incident and angle of refraction. Both will become what? 0. That is what you should remember. Angle of incident, which is equals to angle of refraction, which is equals to 0. All of you should write it. But speed will decreases. When the light is entering from air to glass, and again the speed will increases. Speed up again when it is entering from glass to air. That is what you should remember. Do you understand, Ra? And show variation perfectly. Here you cannot show, but here you can show variation. That is what you should do it. Do it, all of you. So now, after that, all of you keep heading. Effects of refraction of light. And now this meeting is going to end, correct? So now all of you go into your kitchen and take, understand, a transparent glass and fill the water completely and bring it to in front of yours. Go